If we simulate Mendel's F1 generation dihybrid cross, what will we find out?
The genotypes of the next generation, the F2s.
Which will tell us the phenotypes by looking at the dominant alleles.
And it should all follow the law of independent assortment. Let these two chromosome sets represent the chromosomes from the parent plants in the F1 generation. Now, for both of these heterozygous plants, what are the possible genotypes of the gametes that each of these plants would produce?
Well, the alleles separate, so any kind of P could go with any kind of T.
That gives us 4 possible combinations from each parent. Capital P, capital T, capital P, small t, capital T, and finally, small p, small t.
Could we use our monohybrid Punnett square to predict the outcome of this dihybrid cross?
Well, we need a larger square to show all the gamete combinations.
It should be at least 4 by 4, because there's 4 different gamete combinations in every parent plant.
Here is the square. Go to it.
Okay, the gametes for the F1 generation go along the sides.
The gametes combine, and we can fill in the rest of the chart with the genotypes.
Out of 16 possibilities, we only get one plant that is a white flowered dwarf specimen.
Oh, you sound surprised. I bet Mendel was too. What are your phenotypic ratios?
Well, we have 16 different combinations representing all different genotypes. Some are heterozygous for one trait, homozygous dominant for one trait, or homozygous recessive for the other trait. And this verifies the law of independent assortment. One trait has no effect on the other. For example,
the alleles for tallness don't affect the alleles for color. This verifies the law of independent assortment. The alleles for each trait segregate independently during gamete formation and combine randomly during fertilization.
We have 9 phenotypes that are purple-flowered tall, 3 that are purple-flowered dwarf, 3 that are white-flowered tall, and 1 that is white-flowered dwarf. So we get a 9 to 3 to 3 to 1 phenotypic ratio.
Would you expect the same phenotypic ratio if you had a different dihybrid cross?
Yes, if both parents were heterozygous for both traits. You'd fill out the chart the exact same way, just changing the letters to represent whatever alleles you were trying to show. Now, isn't this the mathematical formula that Mendel noticed?
Yes, it is.
If one of the parents was homozygous for one of the traits, the ratio would change, wouldn't it?
Why don't you try?
Well, after I've changed the...